Okay, hello everyone. My name is Mike Jones. I'm the Director of Education with the Oracle Applications and Technologies Users Group. I'm very excited to welcome everyone to this database and technology webinar, Unlocking the Power of AI, Oracle Database 23 AI's Vector Search for Schematic Queries. Um, I'd like to first thank Denovo for sponsoring the Database and Technology Week. These weeks cannot happen without their support. We're grateful for their partnership. They're, true partners of the OATUG too. They always go to Ascend. They exhibit at Ascend, and they do some fantastic sessions. I know our members always love them. Before we get started, I'd like to remind everyone to mark your calendars for Ascend 2025, happening June 8th through 11th in Orlando, Florida, at the stunning Rosen Shingle Creek Resort. Early bird registration is happening now through April 2nd. We hope you all can join us. I'll post links for that upcoming event in the chat area shortly. You can post any questions in the Q&A of the Zoom, and we'll get to those at the end of the webinar. We might handle a few of those during the webinar. If you're interested in receiving CPE credit, you must ask questions in the Q&A, be logged into the webinar for at least 50 minutes, and complete the session survey. And finally, I'd like to turn it over to our presenter for this session for today. His name is Joseph Ernest. He's a Senior Director at Denovo. Take it away, Joseph.
Thank you, Mike. Good morning or good afternoon, everyone, from wherever you are. My name is Joseph Ernest. I work as a Senior Director at Denovo, support managing Oracle Applications and Technology Group. So welcome to the session. Oracle Database 23 AI, Unlocking the Power of AI Using Vector Search for Semantic Queries. As you know, Oracle 23 AI introduced 23C came through, and then 23A was introduced last year with the powerful features of machine language, AI, and a lot of other capabilities that Oracle Database can handle. Particularly today, I'm going to talk about the vector search, which is very, very powerful for your machine language queries and your semantic queries for your business data. So I'm going to go through how it is working and how we can make use of the vector search in your day-to-day business use. I will show you some use cases at the end of the session. So welcome everybody. Just quick update about Oracle Application and Technology User Group. Just a couple of slides. We are all welcome you to become a member and help grow in the technology and Oracle applications enhancement. So when you become member, you can get a lot of discounts and everything for conferences and on-demand recordings. So there are some of the features available here. And you can volunteer in OATG user group. You can be a member, you can be a director, and you can do you have a lot of opportunities to volunteer. As Mike told you, Ascend is coming June 8th to 11th in Orlando, Florida. You are all welcome to attend there as well. Registration is already open. And I want to thank Denovo for sponsoring this Technology Week. Thank you, Denovo, for sponsoring. Again, my name is Joseph. I'm a Senior Practice Director for Oracle Application and Technology Group at Denovo. I'm working with the Denovo for about 13 years, supporting OCI, Denovo Private Cloud, and on-prem customers. 30 plus years of IT experience in database and application support, and 20 plus years experience in EBS and Oracle applications. And recently, I'm also engaged with a lot of OCI technologies at Denovo. Just quick update on Denovo. We are around 290 professionals based in Colorado. We have a great partnership with Oracle, supporting their OCA projects and Oracle Cloud application projects. We also have around 50 on-prem customers and 25 customers in public cloud. and about 20 customers and 70 customers in our own private cloud. And we support various sectors, public sector, um, supply chain, manufacturing, finance, and many of them that we support. We run around 2005, we have done 2000 projects in JDE and around 500 EBS projects, around 30 Oracle Cloud application projects. So we are pretty busy always, mainly supporting most of the Oracle application products. Without further ado, we can go ahead with the topic today. As I told you, I'm just going to focus on the Oracle Vector Search feature, which is available in um, Oracle 23 AI database. What is a vector search? Vector search is just a method of searching for data using mathematical vectors. Instead of traditional keyword search, you typically give some values to search. But in vector, this is all based on the numerical value. Instead of matching exact terms, vector search finds similar data points based on their semantic meaning. Like you can use techniques like embeddings to represent the objects like such as text or images in the vector space. Um, so for example, if we want to search similar images, finding a contextual relevant documents, you can use vector search. In 23AI, there is a powerful feature called retrieval augmented generation is being used. It's just a technique that combines the power of the similarity search along with the contextual meaning of the search that you perform. For example, if we have a e-commerce or retail business, if somebody put a query saying that find all the products that have like a water resistant backpacks for hiking. You may have a data that has a different contextual meanings. Like for example, you may have data based on durable backpacks for outdoor activities or backpacks for rain protection, but the query that you pass will convert them into vectors, and based on the contextual meaning and semantic meaning, it will produce the results exactly in many ways. Same thing, we can use this for medicals, we can use for social media, or you can use in customer support or help desk. For example, if somebody asks you, okay, how to reset my password? You may have your knowledge base articles in a different way. Like for example, your article may say how to recover your account or reset your login credentials, but this particular question is going to convert this contextual meaning and going to present the data exactly based on the meanings. Uh, so that's why vector search is very important. Um, so the relevance, the search relevance is much improved. Unlike traditional keyword-based searches, vector search allows semantic search and the meaning of the search, so it can find the results based on the meaning or context. Even if the exact words or phrases are not present in your document, it's going to convert them as a meaning and it's going to bring results based on that. And also it can handle unstructured data. Many data types like text, images are unstructured, meaning they don't fit nearly into rows and columns. But it's going to search through and find all the related relevant searches for you. And also it's very much scalable. It can handle like large scale data sets such as billions of documents or images, and they are all getting they transformed into vectors, and the vector search happens so quickly and retrieve the results as fast as it can. And also you can personalize. For example, if you're watching some series and based on your previous interactions with the system, it can bring all the relevant data for you. So it can personalize the things. And also it can be used across domains, like many fields are benefited based on this vector search. So this vector search is not only a technique that's used in one place, you can use it in many databases as well. So commonly, vector search is used in across the platforms. Like, you can use cost-effective systems like, open source databases, or in many cases, you can use this. And also, it provides efficient storage. It can improve your response time very quickly, and it can be integrated with machine language, so easily. So we talked about vector search, and what is a vector? A vector is nothing but a numerical value. For example, the vector is calculated based on the feature of the data. For example, if you define a dog can be defined by size, or how fast the dog can run, or or the lifespan of the dog, or all the features that are combined and present a single value called a vector. For example, if you calculate a vector for a car, it can be depend on the car speed, or the fuel efficiency, or the price of the car. So there are a lot of features combined calculate a single value. So it can be easily compared with the other products, the similar products. So it can calculate the distance between those two products and then bring the appropriate results properly. So it's nothing but all the text and images are converted into a numerical value that is stored in the database. So it's used, easily used for comparison of the data. Like I said, it is different from the traditional search, and some of the key differences that I want to show. Traditional search works structured data, like you know exactly what you're looking for. For example, if you want to look for an employee name or employee number, you know exactly, and then you pass that value, and then it will bring you the results. But in vector search, you use the similarity search. Or the pattern search, or semantic meanings. The search approach is a little bit different compared to the traditional search. The search criteria also changes, and it can be used for many applications. Like for example, if you want to use your traditional search for your finance data, because you cannot do a similar search because you want to get exact value. But vector search is in used for a lot of other applications that are needed, and the speed is very much efficient in a traditional search for a mid-range data sets. But in the vector search can be used for high dimensional and unstructured data with millions of rows and millions of documents. Data representation in traditional search, they are defined in rows and columns, but in vector search, they are like numerical arrays. They stored in the numerical arrays, often with thousands and millions of documents and dimensions. Indexing can be used in both the places. Index is used in traditional search, or B trees and hash indexes, but in vector search, there are different type of indexes are being used. Um, Search complexity is very straightforward in traditional search, but in vector search, its complexity is really, really huge. I mean, it grows based on the data dimension, how the data is being stored, and in many ways. Um, the result type is exact matches in traditional search, but in vector search, it can give you the most similar items based on the meanings or contextual relevance of the data. Scalability, as I told you, it's vector search. The unstructured data can scale, very, very, huge, high dimensional data sets, and billions of vectors can be stored. Um, the application type are, varies between the traditional search and vector search. Based on the need, you can use vector search in appropriate fields. Okay. what is beauty about Oracle vector search and how the Oracle uses the vector search in 23 AI. The vector representation of data is stored as a vector in the Oracle database. For example, it's particularly useful for AI and machine language tasks. So it can be derived from various models available, like for example, NLP models, or any other model. You can derive the vectors and store them into the vector database along with your business data. So the beauty is the table itself will contain the vector column, and you can store the vectors next to the business data. So it's very easy to query the using the SQL statements. And as I told you, it uses the similarity search. That's called. We have a lot of built-in functions available that are used for vector similarity search. So when you query a table with vector data, you can use the new vector search capabilities to find most similar vectors to query a vector. The searches, can be used with cosine similarity or even Euclidean distances that you can use to query your data. And it is the beauty of it. You can create indexes based on that. And also, it is integrated with SQL. So we are all familiar with SQL. So the application development becomes more efficient since you don't need to write complex codes or anything. You can use your SQL, traditional SQL statements to pull your data for your need. And the scalability and performance are pretty much improved because Oracle is well known for scalable and performance in the database side. So you can use the same features and expand that to the vector search functionality. So the parallel processing, distributed architecture, and in-memory technologies can be still used for your vector search applications. So the beauty is you already have your business data stored in the database. Now you are just adding an element to that business data. So you can use your existing model along with the vector search that makes your database more powerful. And it's like you don't need to add external functionality to it. Everything is going to be inbuilt, and it becomes really useful for your business needs. Um, like vector data type we talked about. So there will be a vector data type, and vector indexes will be there in Oracle 23 AI. And there are like vector functions. They already developed some of the DBMS functions. You can handle all the vectors. Like you can use vector chunks. You can split the plain text into smaller chunks to generate vector embeddings that can be used with vector indexes or hybrid vector indexes. You can use vector embedding to generate a single vector embedding for different data types. And also you can use two vector from vector functions to convert your text data into vector. And then vector norm will return a Euclidean norm of vector as a binary double. So there are a lot of functions already available. One of the things that we talked about is the retrieval augmented generation is already inbuilt with your 23 AI database, which is more powerful. We're going to discuss about in the coming slides. That is already included in your 23 AI database. And so it can be used all the LLM based interfaces for your applications. So we talked about vector search. There is two different things that I want to talk about. One is the similarity search and how RAG differentiate between the similarity search and when you use RAG, how it differentiates between those two. For example, a similarity search is only focused on finding a related data based on the semantic meaning. That means you have like a huge unstructured data stored in the database, And based on the semantic meaning, it's going to produce the results. So when the user prompts something, it's going to interpret that prompt into the semantic meaning, and it's going to return the results. So whether it's your business data and whether it's data that you are going to convert from LLM, it's all going to be based on the semantic search. So user inputs, and then that will get converted into vector based on the embedding function, and then the vector is going to query the results based on the similarity search, and it's going to produce the results. In RAG, it adding an element to it. It's called contextual meaning. So it uses the similarity search uh, to improve the accuracy and add the contextual relevance to that similarity search. So it becomes more efficient. So it produces more results based on the contextual meaning of the search that you are using. Um, so it can be used for chart paths or any document searches or any language to code synthesis and everything. For example, um, when the user inputs the query, it uses the similar search and it adds the contextual meaning of it using the LLM, and then it gets the relevant data based on the query. So I'm going to show you the example. So I'm going to that will explain you in detail how this is possible, how this is handled. Because when you see an example, you will realize, okay, this is what I can easily understand. Okay, what is RAG and how it is handled? For example, just I'm going to show you the flow of the RAG. RAG is nothing but retrieval augmented generation. It's a framework that combines the strength of a traditional information retrieval systems with generative large language modules like LLMs. Okay, it helps to generate more accurate and up to date relevant text. It allows the developers to provide latest research or statistics or news to the generative model. So when you have the up-to-date information, your query can be more efficient using RAG. Um, so for example, you can use the RAG to provide chartbot access to internal company data and give factual information only from an authentic source, authoritative source. So it's more secured in that way based on the search. Um, so the flow is, for example, if a user asks a question, it sends the prompt chunks to the embedding model, and then embedding model is going to return the vectors, and the vectors are going to be stored in the database, and then we are going to search based on the vector database, and then it's going to produce the top 10K, top K vector results. Like for example, if you want to say top 5 rows or top 10 rows, it's going to produce the results. Then it's going to send the augmented prompt to the LLM, and then the augmented results return back. That gives more relevant data, and then that pass back to the user as a response. So this is the flow how RAG will be involved in Oracle 23a search functionality. So this is why we use Oracle 23 AI because it's vector search. You can add your vector search with your business data, which is already available to augment generative AI functionality. And the search is much improved with your relational and vector search. Combining your relational search and vector search, you can produce a sophisticated result. You can scale out the workload based on your already available existing architecture like rack or sharding or partitioning that can measure your expand your architecture vertically or horizontally, and you can index on your vector data type that gives a fast and accurate results for you. And then it's a very simple, because it's already included in the SQL. You can use the simple SQL statements, so your application development become more efficient and more quick. So you can, create your applications, within given time, and using the same technology that you are already invested in your industry. Okay, so now I'll talk about the vector search. I'm going to show you one quick example, like how the vector search is going to be used. I here used Oracle Autonomous Database to produce these results and to show the example. So the steps are in, some of the high levels I'm going to show you. So you need to set up your database. You need to choose a model for your LLM, and then you need to load that model into the database. So there are a lot of new functions available to load the models, and you generate the vectors. The next step, then you use the search functions based on the vector distance. That's going to create your results. So it's very simple once you understand. The steps are very easy to produce and very easy to use. But all the complexity are built up into the database because they want to simplify the use of it, so that the powerful Oracle database can handle everything behind the scene. Uh, so when you load the model, there are a lot of new DBMS functions available to load the model and to generate the vectors. So I'm going to show you one by one how each step are being done. Setting up a database, it's very easy. There are a lot of free tiers available. If you have a corporate account, you can create a Oracle Autonomous Database, which is always free, as long as you maintain the database runtime and everything. You can use it for free for your testing. And if you don't have a corporate account, you can even get a free account. I think they are still available. And then you can use this example for your testing purposes. So I just used a pre-trained model like mini LM L12 V2, which is available from Hugging Face. So that's what I used to generate the vector representation. These models transform the text into high dimensional vectors, where similar text have similar vector representation. So that makes my demo easy for me. So I can use this model and load it into the database and show you the results. Like I told you, we can use the DBMS vector package. And So I set up the database. Then I load the model, the ONX model, which is an open neural network model that I told you. Um, I don't know if you ever used Oracle Autonomous Database. You can use the data pump directory. You can load anything into the pump directory, and then from that you can load it into the database. So I use the DBMS cloud package to get my object directly from the HTML file that is available as a model and load it into the data pump directory. And from there, I loaded into a model named uh, AL Mini LM L12V2. That's the model name that I used here. So the DBMS vector the package will load that into the model. So once the model is loaded, you can use the simple SQL query to query the model. So there is a user mining models table available. So you can use all your models available here. So if you see the algorithm that's used is Onyx algorithm, and mining function used is embedding. So this is what we are going to use to generate vectors for our business data. Um, so you need to have a model to generate vectors. So once you have the model, you can easily generate the vector for your business data. To generate a vector, you can use vector embedding function. So here, once the model is there, I can see a sample. Like, for example, I can pass a value, quick test. Okay. So it's going to generate vectors for anything that you pass. So quick test is just a simple example that I'm going to pass. So that's going to create some vectors. So these are the vectors. It's very, you know, concise numerical value that it shows all these tests. It's going to keep on showing that. So once you have this vector, you can put it on your database. You can store that in the database table. So the next example I'm going to show you is I found a movie codes information from Hugging Space again. So the movie code has two columns. One is the movie name and the codes about the movie. So I loaded that into the table. Um, Once I have those data into the table, I'm adding a vector column to the table. So that's the vector data type that I talked about. So it's called movie underscore quote underscore vector. That's the column name. So now I'm going to generate vectors for that particular column. So based on using movie codes, I'm going to create vectors for that and then store that vector into the table. So it's going to generate vectors for all the movie codes, and then it's going to update the corresponding row for that vector. So it's going to have numerical values in that column. Hope you got this point. So I have two columns. One is movie name and movie code. So I'm generating vectors for that movie code and then store them into the movie code vector column. So once I have that, it's going to be very easy for me now. Now I'm going to make the prompt saying films with motivational speaking in them. So find all the films that have motivational speaking in them. So it's just very simple query that you pass, right? You are not writing any complex code or anything. You're getting the prompt, you're passing the prompt as a SQL query, and then you're going to get all the codes, all the movie codes that are going to generate um, all the movie names. So as you see, the movie codes are available here. And then we are calculating the vector distance. Vector distance is the one that the row that already has the vector column. And then it's going to create another vector for the prompt that you're processing. So it's going to compare that vector with your stored vector. And then it's going to calculate the distance, the minimal distance for that. And then it's going to display in a descending order. Sorry, in a ascending order, right? The top 5 rows, it's going to list all the queries that are matching. So if you go beyond the top 5, you may see unrelevant data, which you don't need. So you can even take, okay, I found one movie code, that's enough. So I can give that. So these are the movie names, and these are the codes to the corresponding movies. So based on the vector calculation. Same thing in the second example, I'm going to ask for the movie that are films about war. And it's going to, that's the prompt that you're passing, and it's going to calculate the vector for that. And then it's going to compare that vector against that movie code vector. And then it's going to calculate the distance, and then it's going to produce all the movies that are based on war. So here, movie code is a business data. So similarly, you can use your existing business data and generate vectors for that, and produce the results. Then this result passed back to the user, and there you go, they get the result set. I think this is very clear in understanding. So now you know how simplified it is with the Oracle 23 AI, and how efficiently you can use your inbuilt functions to produce your vector search results. As I told you, there are a lot of SQL functions. One is the vector distance we already saw. So you can calculate the vector distance to compare the vectors. And then there is a chunking and vector generation functions that you can use. Like if you have a complex data, you want to create them into chunks so that you can precisely calculate your vectors. So you can use that. There are constructors, converters, and descriptors and arithmetic operators you can use. And JSON compatibility is already inbuilt with the vector data type, so you can use your JSON queries as well. Some of the PL/SQL packages that we can use called DBMS Vector. We already used that in my example. So it's nothing but it simplifies the common operations like with AI vector search, like extracting chunks or embeddings from the user data, generating text for a given prompt or an image, and creating an vector index or reporting on vector index accuracy. Okay. Um, Same thing, DBMS vector chain is available, DBMS hybrid vector that can be used with JSON-based queries and API search. And vector index, as I told you, vector index is available. You can create indexes on the movie quote vector. So for example, it's going to create an index on the movie quote vector. Uh, on movie quotes table, the vector column is this. Organization, neighbor partitions, distance, cosine algorithm it's going to use with target accuracy 95%. So these are the syntaxes. So you can create index for your query efficiently to run the query efficiently. As I told you, this query ran within like 0.33 seconds. I didn't even have any index on this table. This query ran like 0.29 seconds. Um, and I don't have any index. But if you create index, it can run, even much faster than this timings. Okay. We come to the conclusion. I believe you gathered some idea. I know you have to go through a lot of things, but at least you got an idea how the vector search is being used in your uh, existing database structures. Oracle 23a is so powerful. You can easily use your existing uh, database functionality with your vector search and produce the results very quickly. So, as you know, vector search represents a next revolution in retrieving your data, for your business needs. And, it's going to be used definitely in coming years. It's going to be used heavily in all across the platforms and applications. And, it can allow to search and retrieve data, including structured and unstructured data, based on the semantics or meaning of the data with the RAG. Rather than just keywords, it can embed the vectors and store them alongside your business data in the database. So which makes you powerful. And also you can develop applications. You can even make changes in your custom programs. You can add the vector search very quickly to produce the results and make your application development cycle more efficient. I just listed some references. I know this PowerPoint presentation is going to be available for you. So if you want to do more study on the vector search, you can use Oracle document. And also I listed the blog that I used to generate this vector embedding. So they show some examples like how to load the data into the database, Oracle 23a database, autonomous database. So you can follow the examples and uh, test yourself to get the results. Okay. I hope you understand some, at least some of the um, context that I'm talking about based on the vector search. Hopefully, it's helpful in your day-to-day business needs. If you have any questions, you can reach out to me. My name again, Joseph Ernest. You can reach out to me at jernest@denovous.com. And again, thank you for the time, and thank you, Oracle Application Technology User Group, for conducting these sessions, which are more helpful to enhance our skills and make our business more successful. And thank you, Denovo, for sponsoring.
Perfect. Thank you, Joseph. Did you get to that question in the Q&A?
Yeah. Okay. In the diagram, the vector database resides outside the autonomous database. Is that correct, or is that just on the way explanation factor? Let me go back to the diagram. I believe you were talking about this one. The vector store is, so this is just an example. The store is inside the database. As you see in the example that you already, I think this you asked this question before the example. Now you know the example, like it is stored in a table as a numerical value, and then with just a flow of things that happens. The LLM can be stored outside or inside. Even vector store also can be stored outside or inside. But the thing is, now everything is combined into the database. So we also loaded the LLMs into the database, and we also have the vector stored in the database. And all we didn't even go out to fetch anything. So everything contained in the database and made our query more efficient. Hope that answered the question. Thank you.
All right. I'm not seeing any other questions. If anyone has any questions, please drop into the Q&A portion of the Zoom platform. All right, I'm not seeing anything else, so we'll go ahead and conclude this webinar. Thank you so much, Joseph, for presenting. We hope to see you at Ascend presenting as well. I know there's so many, this is kind of opening Pandora's box to what you can do with AI, so thank you for doing
Yeah.
that.
Thank you, Mike. Yeah.
And this will conclude the webinar. Everyone have a great day.
Thank you so much. Thank you, everybody.